In this class, I will be explaining about the covalent bond. What is covalent? When I ask you this question, immediately you have to say it is formed because of mutual sharing of electrons, right? So, covalent bond definition. It is formed because of what? Mutual sharing of electrons between the participating atoms. In covalent bond, both the atoms are equally electronegative. So you can say is a combination of equal, electronegative elements. So generally, this type of covalent bond is formed between two electronegative atoms or non-metals. When I say electronegative, you can call it simply non-metal elements or non-metals. The number of electrons shared by an atom, the number of electrons shared by an atom in order to complete the octet is called covalency. Let us consider chlorine molecule. What is the electronic configuration of chlorine? It is a 17 atomic number. So 1s2, 2s2, 2p6, 3s2, and 3p5, right? So this is K shell, this is L shell, and this is M shell. So each chlorine will have 5 electrons in the outermost shell. So this can be simply represented as the neon configuration because we have got the inert gases like helium, neon, argon, krypton, xenon, radon in the last group that is called the inert gases. So here, what is the atomic number of helium? 2 plus 8, you can add 8. So 10. Again add 8, you'll get 18. Now this time we have to add 10 plus 8, that is 18. Why? Because it travels across the D block. So in D block we have got 10 elements, is it not? 10 columns. So for each column, that is for each orbital, you have to fill up 1, 1, 1 up to 10. So 10 plus 8, 18. So you have to add 18 here. So krypton 36. Again add 8. So it becomes 54. Now this time 18 plus 14. Why? Because it travels along across the F orbit also, F block also. So for F orbital, the maximum electrons are 14. So 14 plus 18, 32. So we have to add 32. So you will get 86. So likewise, you can easily remember the atomic number of the inert gases. Now, which is the closest inert gas for chlorine? You can say neon. So this is 10. So you can write the electronic configuration simply. Put neon 10. So that accounts for 10 electron and the remaining is 3s2, 3p5. This is the easy way of writing the electronic configuration of the given elements. For chlorine, this is the electronic configuration. We can put the box model also. That is, you have the last shell 3s2, 3p5. So 1, 2, 1, 2, 3, 4, 5. So it means you have 5 electrons plus 2 electrons. That is 7 electrons in the outermost shell. So what we are supposed to do? Take this 7 electrons chlorine, chlorine. 2, 4, 6, 7th electron. And similarly, we have 2, 4, 6, seventh electron, right? Now, these may mutually share each other so that it can form what that is Cl dot dot dot, and they are generally shared as a common pair. So Cl dot dot dot. Okay, so it envelopes like this and this envelopes like this. So this leads to covalent bond, and that is simply represented as Cl bond Cl. So both of them has attained the octet electrons, that is 8 electrons here, 8 electrons here. Previously, when they are separate one, it has got 7 and here 7. By combining, there is a coexistence, a stable one, so that each one will have 8 electrons and commonly overlap is 2. So bonding is nothing but what the overlapping of orbitals. Okay, right. Now let us consider one chlorine and one hydrogen in the case of hydrogen chloride. So let us make it like this. H has got 1. What about chlorine? So 2, 4, 6, 7. So they can combine and form a bond also. So here it forms, that is H bond Cl. Okay. Now in that case, hydrogen has got 2, and what about chlorine? It has got 8. So thereby they attain the stability. So here it is called duplet. So duplet is stable, octet is stable. Okay. Now let us discuss the conditions for the formation of covalent bonds. What are the conditions to start? What are the conditions to form covalent bond? High ionization energy, equal electron gain enthalpy, then equal electronegativity. Okay. So for the formation of covalent bonds, the ionization energy of atoms should be high. Okay. So that they are not able to transfer their valence electrons and form ionic bonds. So they maintain. But in the case of electron gain enthalpy, the combining of atoms, the combining atoms for a covalent bond should have equal electron gain enthalpy so that the bond is mutually, the participating atoms will have the mutual sharing of electrons so that bond exists as a mutually shared one. Similarly, electronegativity. Electronegativity means what? Electron withdrawing tendency. So both have the equal electron withdrawing tendency. So there is no much difference in the electronegativity. And thereby, this kind of covalent bond can exist or form. Next. Yes. No, no, no. I will come later because when I say covalent bond, how far these type, wait a minute, how far these are going to exist as covalent bond, that is a different case I will be discussing. And the types of covalent. Next, types of covalent bond. So this is the conditions. Then types of covalent bond. Take down. Types of covalent. Here it can form a single bond or a double bond or a triple covalent bond. So single covalent bond, double covalent bond, triple covalent bond. The single covalent bond is formed by H plus another H so that they can combine to form HH. So it forms a single covalent bond. You can call it H2 molecule, single. Then in the case of oxygen, O and O. So here 2, 4, 6. 2, 4, 6. So the problem here is individually they are 6. So they are not stable. So it means if they have the bond like this, one of the bonds, one of the double bond, pair of electrons come here, so that can be channeled also. So similarly, this one. So it will have the tendency to come here and also here, so that it forms O, two pairs of electron with one single bond, another single bond. So double bond. Then O, a pair of electron, a pair of electron. So this leads to double bond. Now you can check the number of electrons in each 2, 4, and 6, 8. Is it not? So you can take that one also like this. So 8 electron system. Similarly, 2, 4, 6, 8. Because each bond has 2 electrons. Therefore, both of them have achieved 8 electron system, that is octet system. Thereby it attains the stability. So simply it can be written as O2. So oxygen molecule exhibit what? The double. Then in the case of triple bond, let me consider nitrogen. Nitrogen has got 5 electrons. So here 5 electrons, so 2 and 1, 2, 3 you can take. So similarly 1, 2, 3 of nitrogen plus 2 electrons. Now what happens? So individually they are 5, okay? But once they combine like this, now N, okay? Now these bonds are combined. 2, 4, 6, and here, yeah, and here, yeah. Now you count it. 2, 4, 6 plus 2, 8 electrons. Similarly, 2, 4, 6 plus 2, 8 electrons. So they achieve the double bond like this. 1, 2, 3. Triple bond. So it is represented as N triple bond N with a pair of electrons on both sides, the lone pair of electrons. They are also called non-bonding electrons. Then we can explain some of the organic molecules like this also. For example, let me consider ethane. In the case of ethane, what is the formula of ethane? C2H6 is an alkane, right? CnH2n plus 2 formula. So let us have C, another C, right? And you have 4 valency, 1, 2, 3, 4. And this carbon also 1, 2, 3, 4. And what about hydrogen? Hydrogen has got 1, this hydrogen 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 1. Now what happens? CH bond, CH bond, CH bond. And here CH bond, CH bond, CH bond. So now that results CC single bond. Okay, get down. So this is the case with C2H6. So that is why we simply represent C 1, 2, 3, 1, 2, 3, H, 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 H. Okay. Then similarly you can draw the other molecule, that is C2H4 also. that is alkene, that is ethene. So here we talk about the CC single bond, and here CC double bond. So what is the formula? C2H4. Now let us call it C and C. And then we have got double bond. So you can put 2. So the remaining is 4, remaining 2. So you can put 1, 2, 1, 2. For each carbon, 4. And hydrogen, 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 hydrogen. Now you can make a bond. So this is CH bond, another CH bond, another CH bond. And what about this? This is C double bond, C and H, H, H. Okay. So usually it is called the sp3 hybridized orbital whenever you come across single bond. And this is sp2 hybridized orbital. The carbon has got such a tendency. And based on that, we can determine the structure also. Usually sp3 hybridized, they will have the totality ring, whereas the sp2 will have a triangular planar structure. Now let us move to sp hybridized. That is with alkyne, that is ethine, or also called acetylene, that is C2H2. It is an alkyne, so its structure will be C, but you will have a triple bond like this. So you got already 3. So at the most, a carbon can have only 4. So 3 plus 1, 4, 3 plus 1, 4. So it can have only one hydrogen and one hydrogen. Now CH bond, another CH bond. Now CC triple bond, and with two CH bonds only. Okay. So this is called sp hybridized. So this is triple bond, triple covalent bond. And they have the tendency to form a rod-like structure. Now let us discuss about the characteristics of covalent compounds. That is, compounds based on covalent bond. Characteristics of covalent bond. So when we say characteristics, you should note the physical state first of all. Secondly, you should be aware of the low melting and low boiling point. Then let us discuss about the solubility aspects also of covalent bond. How about the solubility in water, that is in polar solvent and in non-polar solvent, etc. Then we'll discuss about the electrical conductivity. So, electrical conductivity. I'll explain. Then molecular reactions. Molecular reactions. And then the directional characteristics and isomerism. So these are all the important characteristics of covalent compounds, directional characteristics, and more importantly, the isomerism. Now let us discuss one by one. Let me take the physical state. Usually, covalent bonds or covalent compounds, they exist in all the three states, solid, liquid, gas. They usually contain molecules rather than ions. Regarding the boiling points and melting points, they have low melting point and low boiling point. Why? Because of the presence of weak force of attraction. Weak force of attraction. As I said, they are existing as molecule means intermolecular forces are weak. We have already discussed about that. So the weak force of attraction between molecules. What do you call that? Intermolecular force of attraction. This can also be called dash. What is that? Cohesive force or van der Waals force. And if it is a partly electrostatic, then it can lead to dash, hydrogen bonding. Okay. But anyway, these are all weak forces only. Compared to ionic bond, they are weak. And that is why the compounds are low melting and low boiling if it is a liquid. Then, but the covalent compounds generally having hydrogen bond can be dissolved in water. So that under solubility, I will discuss that as well. Now, as I already mentioned, they are non-polar. Since they are non-polar, they are soluble in non-polar solvents only. Okay. Non-polar solvents example benzene, toluene, xylene, etc. These are all petrochemical bonds. Carbon tetrafluoride. So here the concept is like likes like. It means like dissolves like, right? Not like the charges, where unlike charges attract each other. But here, as well as solubility is concerned, non-polar compounds are soluble by non-polar solvents. Polar compounds are soluble by polar solvents. But there are some exceptions. In this case, the compounds having H bond, they can be soluble in water because of the formation of H bond. Then electrical conductivity. Since there are no free ions, there are no free ions in covalent compounds. To conduct electricity, they are bad conductors, that is insulators of electricity. But there is an exceptional case. Graphite is an exception. And then the directional characteristics and isomerism. And I was talking about the molecular reaction. We discussed this one. So these compounds are molecular in nature that we already discussed. So their reactions are also molecular and proceed at much slower rate as compared to ionic compounds. So the reaction speed is less than that of ionic reactions or ionic compounds. Why? Because covalent compounds are basically molecules. Then directional characteristics and isomerism. Since the covalent bond is localized, since the covalent compound is bond is localized between the nuclei of atoms, it is directional in nature. It is directional in nature. So it means the atoms can take different direction or different arrangement. So different arrangement in different direction. And they are responsible for the structural isomerism. What do you mean isomerism? That is, molecular formula will be same, but structural formula is different. And they lead to such kind of stereoisomerism also. Stereoisomerism means that is stereo means the space. So spatial arrangements of atom will be different because they are capable of extending in different directions. So these are the key characteristics of what? The covalent compounds. So what are the important characteristics of covalent compound? Number one, first one, physical state. Second, low melting, low boiling. Third, solubility. And fourth, electrical conductivity. And fifth, molecular reactions. And sixth, directional characteristics. And the stereo, I said, stereo means different spatial arrangement. So the same molecule will be looking alike, but their spatial distribution will be different. So under isomerism, I'll be explaining in detail about that. For example, let me say there are two CH bond like this, and as in another case, it can make a bonding like arrangement like this. So it is differently located. So because of the directional one, direction capacity, so they extend in different direction and thereby it exhibits two types of isomer. So stereo means space. So space-wise, their distributions are different and hence it can result in different types of isomer. Isomer means molecules having the same molecular formula, but it will be having different structure. Such type of isomers are called structural isomers. When they are space-wise, their bonding positions are different. They can be called a spatial isomer or stereoisomer. So we'll be discussing about this in detail under a separate topic. Then classification of covalent bonds based on electronegativity. Classification of covalent bonds based on electronegativity of atoms. So depending upon the electronegative nature of combining atoms, the covalent bonds can be of two types. One is non-polar, non-polar covalent bond. Another is polar covalent bond. When a covalent bond is formed between two atoms having almost the same electronegativity, like in the case of H2, O2, Cl2, etc., almost since they are the participating atoms are same, so the covalency will also be same. So non-polar, the electronegative will also be same. So such type of covalent bonds result non-polar covalent. But in the case of that is covalent bond formed between atoms having significant difference, slight or significant difference in electronegativity, significant difference in electronegativity. Such bonds will be trying to shift the pair of electrons towards the more electronegative atom. So probably in the initial stage, I would have told that this is also covalent bond and they are equally shared. But because of the difference in the electronegativity, there will be a partial negative and partial positive character here. So this type of bond is usually formed between two dissimilar, dissimilar atoms, and they can be called heteronuclear atoms also. Whereas here they are similar, that is a homonuclear. So that is why there is an existence of polarity here. Okay. So and that results the polar covalent bond. Similarly, HF, when you take fluorine has got more electronegative than hydrogen, so now it becomes a partial polarity here. Similarly, you can even take water. So H, but this is not linear as we mistake. It will be triangular only. We will discuss in detail about the shape of water. That is because of the repulsion between the two pairs, lone pairs, and that is according to Vesper. So we will discuss later about this. But let us assume. So in this case, so here it is more minus and this is plus and this is plus. And that is why you can find these are all the polar covalent bond. And under this topic, we are supposed to discuss the Lewis structure. So we already discussed in detail about the Lewis structures. So let me go fast and if time permits, you can go through the previous lectures or videos also. For example, let me consider the molecule or ion. So here Lewis representation, but you should be able to arrive at the Lewis representation like this. Okay. For example, hydrogen means it is represented by H bond H, a pair of electrons between hydrogen and hydrogen. Ozone, O3. So here O and you can put O here and another O. Now how it forms? There is two pairs like this and here two, two. And here also and since one pair of electron is transferred here, it becomes plus. And here there is a formation of single bond. So 2, 4, 6. Now you count it 2, 4, 6, 8. So octet configuration. What about this 2, 4, 6, 8? Octet configuration, right? And what about this 2, 4, 6, 8? Octet configuration. Okay. But, and as I already told you, there is one electron, not two electron. I must put one. So one electron is lost here. Okay. I'm sorry. Two. Excess here. For example, you just counted 2, 4, 6, and it has got 8. It means that is one electron has, I mean this one, not this one, this one. Okay, you take like this 2, 4, 6. One electron is lost as far as oxygen alone is concerned without sharing. And what about this 2, 4, 6, 8? One electron is excess. And that's why you are able to get the bond like this. Now let me explain with the bond. 1, 2, 3. Now two pairs, double bond, and here a pair of electrons, and here another pair of electrons, two pairs of electrons, and here only one bond. But 2, 4, 6. Now you can count 2, 4, 6. Is it not 2, 4, and you have 6. And what about here? 2, 4, 6. Here 2, 4, 6 and 6. Okay. So originally how many electrons were there for oxygen according to electronic configuration? O8 means 1s2, 2s2, 2p, how much? 4, right? Are you able to follow? But here it has got 2, 4 and this one 2, 4, 5. One electron lost, put plus. And here 2, 4, 6, 7. One electron gain, so put minus. So this is the way you have to address. Okay. Then CH4, methane. So for methane, it's very easy. 2, 4, 6, 8, hydrogen, 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 hydrogen. So I have reproduced the complete list in our web notes. You can go through all those things. Okay. Uh, what is the term? Just now I was explaining. Wouldn't you closely follow me? Let me repeat once again. What is the atomic number of oxygen? Tell me. And how many electrons are available in the outermost shell? Huh? Six. Now count it. Tell me. Count it. Two, four, six. Right? Correct? Okay. And as alone, stand alone. And what about this? Count. How eight? Seven. Only one electron. You should not take the other electron. Variable follow. So this is six. This is seven. And this is five only. Because one, two, three plus two, five. Right? But when they are arranged or organized like this, how they become stable? It is because of what? The involvement of the other two also. So thereby they can attain. Okay, so this will they themselves they get adjusted here, and that is why we indicate by the charge here. Then, and in fact, I have detailed about this under UV structure. You must be able to work out the UV structure according to the rule I have already given. Please work out. Try to get me that. And if you are unable to get this structure, then you ask me. Okay. There. So this is regarding Lewis structure. Okay. Then let me introduce one more molecule so that you will have some more idea about that. Nitrogen fluoride. trifluoride. So here nitrogen, fluoride, fluoride, fluoride. So here, what is the atomic number for fluorine? Tell me, what is atomic number? So you've got the p block elements you starting from boron, carbon, nitrogen, oxygen, fluorine, and about this helium here, neon, right? Correct. So boron is 3, 4, 5, 6, 7. So fluorine is 7. So what is the electronic configuration? 1s2. Tell me, 2s2, 2p, 3. So it means you've got 5 electrons. Okay, right? So everywhere that is we have to account for 5 electrons. Now you've got 2, 4, and you have here that is 7. I'm sorry, that is, let me check, boron, carbon, nitrogen, oxygen, fluorine. Correct. So 7. So 2, 3, 5 plus 2, 7 only. Okay, 5. Right? And here you have F and here you have F. What is the valency for nitrogen? Huh? I think it should be, mm, is it 7 or 9? Fluorine. Nitrogen, how much? 7. Is it correct? See, fluorine is 9, not 7. Nitrogen is 7. So this is for, I think that is 1s2, 2s2, then 2p5. Correct, 7. And for nitrogen, 7 means how much? 1s2, 2s2, 2p. So in this case, 5 electron, here 7 electron. So fluorine is 9. Okay. Uh, now listen. Yeah, I have made a mistake here. Actually, carbon is 6 here, right? Boron is 5. So nitrogen is 7. And here oxygen 8. And then 9, right? Neon 10. Got it? So for nitrogen, I have given the electronic configuration. For fluorine, I have given the electronic configuration. So let us work out for fluorine, 5 plus 2, 7. So 2, 4, 6, put 7. And what about nitrogen? Nitrogen has 1. So we can accommodate one nitrogen here. So we are able to get a bond like this. Okay. So this is a commonly shared one. Similarly, 4, 6, 7. Okay. Similarly, 2, 4, 6, 7. Okay. And what about nitrogen? 2, 4, 6. Right? Not 2. 1, 2, 3 plus 2, 5. Are you able to follow? So the nitrogen can be marked like this. Into. Okay. And 1 into, into, into. I hope now it is easy for you to go there. To show the electronic configuration as well as the structural Lewis structure. Okay, so N of 3 will have such a type of structure. Now, that is what about the nitrogen? It has got 2, 3, 4, 5, right? Fluorine dots are of each has 7. But as a combined one, 2, 4, 6, 2, 8, octet configuration. 2, 4, 6, 8. Octet is obeyed. Here 2, 4, 6, 8. Octet is obeyed. And what about nitrogen? Are you able to see that? 2, 4, 6, 8. So this is also stable. Okay. So in a Lewis structure, you can establish all the participating elements are stable by the octet configuration. Okay. Do you understand this? Right. So you have to practice and generally you will be able to write down electronic configuration. Okay. Now let us have some practice. Take down. Based on that, we can, what is the use of this, what do you call writing all these Lewis dot structures, etc., based on which we can explain about the formal charge. Take down. We can calculate the formal charge. And what is formal charge? It is given by Fc is equal to the valency electrons minus the lone pair of electrons minus 1 by 2 of S, where S is the total number of bonding, that is shared electrons. S is the total number of, what is that? Shared electrons or bonding electrons. Bonding electrons. What about L? L is the non-bonding electrons or lone pair of electrons. So total number of lone pair electrons, LPs. And what about the V? V is the total number of valence electrons. Number of valency electrons. Okay. So that is called Fc. So Fc is nothing but total number of valence electron minus the lone pair of electrons minus the half of the bonded pair of electrons. Okay. So don't forget this formula. And based on that, you can work out the formal charges. Okay. Take them. Calculate the formal charge on each atom, on each oxygen atom, right? Of what do we say? Shall I take ozone once again? O3 molecule, so that you can understand better. Now take the ozone structure. How about the ozone? O, double bond on one side, single bond on the other side, right? And you've got 2, 2, and here 2, here 2, 4, 6. Let me identify by 1, second oxygen, third oxygen. So let us work out one by one. So the oxygen atoms have been numbered as 1, 2, 3. Let us work out. The central oxygen atom, that is marked as 1, right? So let us calculate the Fc for this. Okay. So Fc of 1. Tell me, what is the formula? Fc is equal to what? L minus half. Yes. Okay. Now tell me, F, Fc1, that is for oxygen. What is total number of electrons, valence electrons? How much? For oxygen, you got 8, 1s2, 2s2, 2p4 means 6 valence electrons. Okay, so valence electron 6 minus how many lone pair of electrons are here? You have to put 2, so 2 electrons. Okay, and then minus, right? And how many bonded electrons here? 1, 2, 3. 3 into 2, 6. So 6 by 2. Okay. So that is equal to 6 minus 2 minus 3. So that is equal to 6 minus 5 is equal to 1. So the charge is plus 1. Take out. So you can put plus 1. I hope now you should be able to understand why I put plus 1. Do you understand, Shanvi? Right. Then let us move to the second one. Second, FC2. Now tell me 6 minus 6 minus and there are 4 minus and how many bonded electrons? That is how many electron bonded electrons are there? 4 by 2. Okay, so that is equal to 6 minus 4 minus 2. So it means 0. So FC2 will be 0. Okay, so here you can put 0 means neutral. Are you able to follow? Now let us check the third one. Tell me FC 6 minus how much? 6 then minus 2 by 2. So it means a 0 minus 1. That is minus 1. So you are able to get the minus. I hope now you should understand why I put the minus 1. Is it clear now? Okay. So this is the way you have to obtain the formal charges. Okay. Right. Now, shall I give you one more exercise like this? One more problem? Take it. Calculate the formal charge of each atom. Calculate the formal charge of each atom of carbonate anion. Carbonate anion or carbonate ion or anion. So first of all, you should be able to arrive at the UV structure of carbonate anion. Can you do? Right? I will get you the clue. What is carbonate? CO3 2 minus. This is called carbonate anion. Okay, so first you establish the Lewis structure of carbonate anion, then proceed with the formal charge. Can you do? Try. Here you can take the carbon first. That is the central atom. Okay, and then you have oxygen here, another oxygen here, another oxygen here. Okay, got it? Write down this first. And what you are supposed to do, what is our general rule for writing the electronic configuration, Lewis structure, what I told you, just to calculate the individual electronic configuration and based on that the valence electrons. What are the valence electrons? For carbon, it is 4 and for oxygen, 6. So you have to account for and first of all, what you are supposed to do, totally how many electrons? 6 plus 4, 10 electrons. And the 6 and there are 3, so into 3 means how many electrons totally? 18, 22 electrons. So you have to account for 22 electrons and first you have to establish with single bond, right? Okay, so single bond, single bond, single bond. Okay, so single bond means each bond has got 2 electrons. So 3 into 2, 6. So subtract 6, remaining how much? 16. Now what you are supposed to do? Identify the most electronegative atom and put the pairs of electron, right? So all are most electronegative atoms compared to carbon. So let us give the weightage here. So total is 16. 16 means 2, 4, 6, right? Similarly, 2, 4, 6. Okay. 2, 4, 6. How many? How many lone pair of electrons I have spotted here? 6, 6, 6, 18. Okay, it is 6, 6, 6 means 18. So, but we have got only 16. So, what we are supposed to do? At the same time, the carbon has got one more electron, is it not? Carbon has got four valency, four electrons. So, 1, 2, 3, we have to account for 4. How we can go about? We can make this here. So, make it as a double bond. So that one bond has gone. Now you count it. 2, 4, 6, 8. 8 electron system. Got. 2, 4, 6, 8. Done. 2, 4, 6, 8. Done. Finished. Okay. Now listen. Here I said that is a 2 electrons. CO3, 2 minus means you have to add the 2 more electrons also. Okay. Because CO3, 2 minus. Are you able to follow? Let me do once again. Just a minute. Um, Let us take up this. Fc of each atom on CO3 2 minus. C, how many? 4 valence electrons. 3 into O means how many? 3 into 6, that is 18 electrons. And you got the charge. The charge is minus 2. So you have to add 2 minus. So totally 24. So you have to work out 24. Okay. Now put carbon, oxygen, carbon, carbon, oxygen, oxygen. Now listen, you have got 24, right? So 24 means first one bond, second bond, third bond. So single bond I have put how many counts? 3 into 2, 6 electrons gone. So 18. Are you able to understand? Shanvi, are you there? Are you following me? Right. So 24 minus 6 is equal to, stay on camera. 24 minus 6 is equal to 18. Now listen, this 18. Now what we are supposed to do? Allocate the pairs of electrons to the most electronegative atom. Which are the most electronegative atom here? Oxygen. There are 3. So each I can put 2, 4, 6. 2, 4, 6. 2, 4, 6. Okay. So 3 into 6, how much? 18. Right? So when I put 18, okay, everything has gone. And how to account for carbon? So what you can do? You can move one pair of electron like this. Okay. Now a pair of electron can be shifted here. Then 24 minus bonded electron. 1, 2, 3. Each bonded electron has got 2 electrons. So 3 into 2, 6. This represents the bonded electrons. This 18 represents the lone pair of electrons to the electronegative electron. Got it? It means you have not gone through that video. Repeat it once again. Okay? Then only you can understand. Now, I have given a bunch of videos also in this regard for structure, I mean Lewis structures. Go through once again. Now listen. So a pair of electron is shifted here, right? So now you account one double bond and here then C and put O, pair of electron, pair of electron, pair of electron, and then O, pair of electron, pair of electron, pair of electron. Is it clear now? Okay. Now, ultimately, this is 2 minus, okay, because of excess of 2 electrons. Now, listen, in this case, 2, 4, 6, 8, done, okay. And what about this? 2, 4, 6, 8, done, finished. And what about this? 2, 4, 6, 8, finished. And check the carbon also, 2, 4, how much? No, no, no. 2, 4, 6, 8. So carbon has also achieved 8 electron. Is it clear? So this is stable structure. Okay. So this is the Lewis structure. Based on this Lewis structure only, you can account for what? Formal charges. So shall we calculate the formal charge of carbon first? Do you tell me? Look at the structure. Now formal charge for carbon, central carbon. Tell me, what is the formula? Valency electron minus lone pair of electrons minus half of the bonded electrons. Okay. Now, valence electrons for carbon, how much? You have got already 4, right? 4 minus. What about the lone pair of electrons here? No lone pair of electrons. Put 0, right? Carbon has no lone pair of electrons. And what about the bonded electrons? How many? 1, 2, 3, 4. 2s are 8. Okay. So 8 divided by 2. So in that case, 4 minus 0 minus 4, that is equal to 0. So carbon has a 0, okay, formal charge, take down. So you can put 0, okay. Then, now shall we work out for this one? Oxygen. So let us label the oxygen as, let me label the oxygen as, let me put the first oxygen, second oxygen, third oxygen, okay. So let me identify this as C number 1. I mean O number 1. Now tell me, what is the valence electrons for oxygen? 6. What is how many lone pair of electrons for oxygen here at 1? 4. Minus a half of 4 by 2 plus 2, 4 by 2. Okay. Now 6 minus 4 minus 2. That is equal to 0. Okay. So you can put 0 for what? This one. 0. Okay. Then O of second one. Tell me, 6 minus, is it correct? How? Lone pair of electrons, 1, 2, 3, 2s are 6. Then minus 2 by 2. Okay. So it means again 0 minus 1. That is minus 1. So you can put 4. That is minus 1 for this oxygen. Okay. Now listen to me. Go to the next one. O3. And this is also the same setup. Okay. So 6 minus 6 minus, and here also 2 by 2 is equal to minus 1. So it has got minus 1. Are you will follow? So this is the way you have to find out. Got this point? Okay. So are you thorough here? Shanvi, shall I give you one or some like this? Try this sulfur dioxide. Try me. You can try sulfur dioxide. Bond parameters. We have various characteristic features of a bond are shown by a bond, and they are called bond parameters. That is, the properties exhibited by the kind of bond. So they can be called bond characteristics or bond parameters. And what are those? One, bond length. Take down. Two, bond angle. Three, bond enthalpy. Bond enthalpy. Four, bond order. Bond order. So all these four properties or parameters are very, very important. Take down the first one, bond length. Bond length is nothing but the equilibrium distance. The equilibrium distance between the nuclei of the participating atoms or bonded atoms in a molecule. That is called bond length. For example, let me call it A and another atom B. I note it down. So this is A, this is B. These are the two participating atoms or bonded atoms. The center of the atom of B is here and here A. So the distance between them means you can take like this distance. It is nothing but the internuclear distance. Okay, so that is D. And this is nothing but the radius of A. You can put RA. And what about this one? This is the radius of atom B, that is RB. So the bond length is nothing but RA plus RB, right? The bond length is nothing but RA plus RB. In the yeah, B represents the bond length. What did you ask? Just 5 minutes more. You have got only 27. 3 minutes more. Ah, so you want me to continue in the next class? Okay. Right. See you tomorrow. Okay. Bye.